who also is CEO of Keyshell. Is my am I audible?
Yes, you are audible.
Okay, myself Vyshak. I'm coming from Thrissur. I have started my career as a Python developer, and after a while, I switched to DevOps at Keyshell IT Solutions. Okay, and now at Keyshell IT Solutions, we are managing both development projects and DevOps projects. Okay, so let's get started. So we all have heard about DevOps, and the term DevOps have come from the development and operations, both combined together. Came the word DevOps. Okay. So today's agenda is first we will talk about cloud computing, then the history of DevOps, then what is DevOps, then why DevOps, and then some development, release, and deployment concepts of DevOps, then some infrastructure concepts, then pipeline, DevOps lifecycle, and some DevOps tools. Okay. So suppose earlier we have a e-commerce website. Consider earlier we have an e-commerce website. Okay, and we have it on the era on which the cloud computing was not popular. Okay. Okay, so on that era, if what we have to do to host our e-commerce website is that we have to run some servers from the data center. Okay, we have to run the servers from the directly from the data centers. We have to run the servers. Okay, the problem with that is if for renting from data centers, we need to give them our requirements. Okay, we will give the requirements like we need this much amount of RAM, this much amount of CPU, this much amount of storage space, and all we will need. We will give them, and on that they will provide n number of servers. Suppose they provide 100 servers. Okay, so we now have 100 servers for running our e-commerce website. Okay, this was before the cloud computing era. Okay, then we have these 100 servers. Okay, then suppose if the traffic in our website increases. Okay, if the traffic in our website increases, we now have heavy load in our these 100 servers. We have heavy load. Okay, so we have to use more than 100 servers. Like we have to use 150 servers. We cannot do that in if we use data centers. We cannot do that. We have to request for an extra 50 servers. We have to request, and we have to pay them, and that was the process. Okay, so scalability was a big issue for using data centers. Okay, and for if we consider on some time, if we have only very low traffic, like on that time we only need like if we only need 10 servers on very low traffic period, we only need 10 servers. Okay, at that time also we have to pay the data centers the fee of 100 servers. Okay, so we will be facing some losses because we at the at that when traffic is low, we have to pay huge amount. When traffic is high, due to heavy load, our website will be very slow, and we will be facing losses. Okay, so to overcome this, cloud computing come into process. Cloud computing is the delivery of computing computing services, which can include servers, storage, database, networking, etc. So if we come to cloud services, there are many cloud service providers like AWS, Azure, Google's GCP, and all. When we host this same e-commerce website in this cloud services, we can pay for the cloud services you use. So that in the earlier case, if we at the low traffic period, we can pay for that 10 servers only, and for if the traffic become huge, we can scale the servers to a very large amount of a very large number. We can scale up easily. That's the main advantages of using cloud computing. Then while using the data centers, there will be an underlying infrastructure. There will be servers, networks, and there will be switches, and there will be many underlying infrastructure. That infrastructure also we have to maintain. If we earlier at the earlier case, that infrastructure also we have to maintain. But while coming to cloud computing, we don't need to maintain that infrastructure. Our cloud providers will maintain the infrastructure for it. So our operating cost will be lower, and the infrastructure can be run more efficiently. And we can scale our business. As the traffic grows, we can easily scale our business. And there are 3 types of cloud computing service models. First one is infrastructure as a service. This provides compute and storage services. You all will have heard about virtual machines, right? Virtual machines is nothing but a very large a server will be divided into virtual machines. Virtual machines, if we have one big server, it can be divided into many number of virtual servers. Then the main use case of that is we can run Ubuntu in one server, we can run CentOS in another server, we can run Red Hat in another server. Like that we can use, and the storage and memory also will be divided between these virtual machines. This was the earlier case on premises. Here we have to manage all these things. We have to manage, that is networking. We have to manage the storage, the large number of storage we have to manage. While coming to cloud compute, we only pay for the storage we use. While data center, we have to rent the large amount of storage at the time of renting itself. We have to pay for it. But while coming to cloud computing, we only need to pay for the storage services we are using. Then so there will be many servers, and then virtualization will be there to create more and more virtual machines. Virtualization will be there, and there will be an OS will be there, for most of the DevOps or most of the web hosting and all, and for application development, etc. We will use Linux. So underlying there will be an OS, then there will be a middleware. Middleware is used for communication between the other layers. Then there will be runtime. The our application runtime is the other applications which are needed to run our application, run our main application. Okay, then our application data and our application. Okay, this was the case in on-premise. Okay, so we have to manage everything. We have to manage. Okay, then in infrastructure as a service, it will offer a compute and storage services. This is infrastructure as a service. Okay, here this diagram is of Azure. Here we can see the virtualization, server, storage, and networking is managed by Azure itself, and we only have to manage the OS, middleware, runtime data, and application. Like for example, Amazon EC2. Amazon EC2, you may not have heard. Amazon EC2 is a AWS service on which we can launch virtual machines. Okay, I will just show one. Here we can launch an instance. We can choose the OS. Which OS you need, we can choose it from here. Then here we can choose the instance type. Here we can see one CPU, 1 GB memory. Here we can select from the different types of instances, like 2 CPU, 8 GB memory. Like that, we can select from our use case. We can select, and we can also configure the storage. Here we can configure the storage, and for the storage, only we only have to pay for the storage we need to use. Okay, that is infrastructure as a service. Okay, so basically it will be providing a simple server, and we will select an OS in it, and we will run our application in that. Okay, that is infrastructure as a service. Example, AWS EC2. We can run. For example, if we have to run WordPress, we will install PHP, MySQL, etc. into that instance, and we will run the service. And we can use this service for other purposes also, like for compiling the software, compiling our application, etc. We can use this. Okay, and the next one is platform as a service. Okay, here in platform as a service, it offers a develop and deploy environment to build cloud apps. Okay, here we can directly deploy our application. We don't need to maintain the instances and all. We don't need to virtual machines and all. We don't need to maintain. We can directly deploy our application with data, with the application data and application. We can directly deploy the application. Rest everything will be managed by our cloud provider. Okay, that is called as platform as a service. For example, AWS Elastic Beanstalk service is an example for platform as a service. Here we can directly, for example, if we have a WordPress application, we can directly deploy an AWS application through this. Okay, and the next one is a software as a service. This will be more familiar to you. This delivers apps as a service. We have all, for example, Google Drive. In that everything is maintained by the cloud provider. Okay, everything, even the application here will be Google Drive, and that also will be maintained by the cloud provider. We only have to log into our Google account, and we can upload or download data from our account. Okay, these are the three types of cloud computing service models. Okay. Then you might have heard about the term SDLC. SDLC is the software development lifecycle. Okay, SDLC is the process followed for a software project within a software organization. The different organization will follow a different approach for their development. Okay, so it will contain a detailed plan on how to develop, maintain, replace, and alter specific software. Okay. In SD, the main process of the software development will be mentioned in the SDLC. Okay. There are two SDLC models, that is waterfall model and agile model. Okay. This is one picture of waterfall model. Here we can see that first the requirements is gathered from the client, and then the design process is started. Then with the design, development process is started, and testing is done, and then deployment is done, then maintenance is done. Okay, the main disadvantage of this model is we cannot traverse back to the previous step. Okay, we cannot traverse back from development to while on development we will not gather any more requirements from the client. Only after completion of each step, and when the maintenance is started, only we will go back to gather requirements from the client, and the design process is again done, and development is done, testing is done, deployment is done, and then again maintenance. So the main disadvantage is lack of flexibility. Okay, since it follows a sequential and linear approach, and there is lack of flexibility. Means the client has to wait for a long period for his or her requirements to be satisfied. Okay. Then limited customer collaboration. Here only at the first stage only the customer is involved. Then only after deployment the customer will get the end result. Then the customer will again provide some requirements. Likewise, it will go. This model is only recommended for small projects, and only for that only this model is recommended. Okay, then it will be a longer time to market. Likewise, like I said, due to sequential nature, this model often results in longer development cycle. Then each phase must be completed before moving on to next. Okay, and this is this is for waterfall model. Then next model is agile model. In an agile model also, the main disadvantage is that it only focus on development side. On operations side, we know DevOps is for development and operations. Okay, but in an agile, it only focuses on the development side only. Okay. Okay, this is an agile model. Here, but we can traverse back to the previous step, and here the development process is done in sprint nature. That is, if one task is done, its testing will be done and it will be deployed, and it will then other task will be done. It will be the testing will be done, and it will be like that sprint wise development and is done. But the but here the main disadvantage is they only focus on the development side. Okay, then comes the DevOps. In DevOps, DevOps is a culture of philosophy that combines software development and IT operations to enhance collaboration, communication, and efficiency within an organization. Here, both the development team and operation team will be working together. Okay, working in a very collaborative manner. They will be working together for the development process. Okay, DevOps mainly aim to bridge the gap between development team and operations team, because earlier there was very huge gap between the development team and operations team. What was done was a development team will develop the application, and they will not give proper communication. There will be not a proper communication with the operations team on how to run the product, and what are the system requirements of the product, and what all packages they need to install to successfully run the product, etc. They will not give proper information to the operations team. Okay, so DevOps aim to bridge this gap between development team and operations team. That will enable them to work seamlessly to the software development lifecycle. Okay, there will be developers and testers, and there will be IT ops, and combined together, it is called DevOps. Then what are the main advantages of DevOps? While using DevOps, we can deploy the applications faster into the market. Okay, if continuous integration, there is a term called continuous integration, continuous delivery, or continuous deployment. We use it is called as CI/CD. So using CI/CD, we can release the product faster into the market. Okay, CI/CD is continuous integration and continuous delivery. Okay, continuous delivery, continuous integration, and continuous delivery. In DevOps, we will use many tools to collaborate between the operations team and developer teams. Okay, for example, if a code is pushed to a repository, there will be a version control system used. There will be a version control system will be used for a development purpose. There will be version control system used. Okay, version control is nothing but like if we have some code and we need to many people will be contributing to the same code. Okay, so we need to know who contributed which code and all we need to know, and we will have a central repository which will have the final code. Okay, there will be a final code, and there will be some we will create some branches for development process. Okay, and then after testing, if the test is a success only, it will be merged to the main branch. Okay, that is version control process. We will come to that. Okay, so So because of that, we can deploy our product faster into the market. Okay, and then like I said, the collaboration between the development team and operations team is improved after using DevOps, and many tasks will be automated. So the efficiency will be overall efficiency of the company will be increased. Okay, so many automation tool and practices are used for using DevOps. So the overall efficiency of the company is also increased. Then while in waterfall model, like I said, we only take the feedback after the deployment. Okay, in DevOps, we will take the feedback continuously. We will take the feedback, and with that feedback, we will again plan it, and we will go to the next step. Next step, we will go to the next step. Okay, then higher quality and stability. DevOps always ensure higher quality for our code and infrastructure, also infrastructure and security practices, etc. We higher quality and stability is maintained. Okay, every time a code is pushed to that repository, it will be tested for any vulnerabilities, etc. It will be tested. Only that it will be deployed to the main branch. Okay, and then scalability. And like I said, we can monitor our application, and if heavy load comes into our application, we can scale up or scale in. Like we can move to 150 servers, or we can move down to 10 servers, so that it will be it can be scaled very easily for while using DevOps. And we can also there will be many servers like build servers or and dev servers, etc. There will be many servers. We can switch off these servers, and uh, we can save some cost by switching off or scaling down the servers. Okay, that also can, and this all can be automated. Like we can switch off the dev servers on weekends, etc. This all can be done. Okay, so it will be more cost efficient. Then some development, release, and deployment concepts. First one is version control. Version controls records changes to files or sets of files stored within the system. That is like we use version controlling. Like if we use Notepad, we can control set. We can, if we press control set, we can undo to the previous version. Okay, likewise, while in development, we can use version control systems like Git, Basa. Like there are so many version control systems. The mainly used version control system is Git. Okay. Okay, and this is what a version control system looks like. Like if there is one computer A and computer B, it will have some code, and it will have many versions. Okay, it will have many versions. Okay, then this is the server computer, which will have the main version, and version 1, version 2, version 3 will be here. Okay, suppose if computer A is developing some code, and after developing, the code will be uploaded to this server computer. Okay, after uploading to server computer, some testing is some testing will be done, and if the testing is success, it will be approved. Okay, then that will be the main code. Okay. That is called version control. Okay. Likewise, we will have version control in Google Slides also. We will have version, like we can see the edit and all. We can see here previous edits. We can see here, and we can make that the main branch. We can make that the main slide and all. We can make that. That's called version control. Okay, the source code, we will while developing our application, we will have some source codes and all that will be stored in this version control. Okay, then a trust-driven development. Like I said, after pushing the code to the repository, some tests will be done. Okay, then continuous integration. After pushing the code to actually what will be actually I will go through this tool, DevOps tools. Actually, this is the life cycle of DevOps. First stage is planning stage. Here here the planning here the requirements is gathered in this stage. Okay, for every stage we will be using many tools. Okay, for planning stage we will be using tools like Jira and all. We will be using in planning stage. Okay, in code stage we will use tools like Git. Here also we will use Jira, and there is a documentation tool called Confluence. Likewise, for this coding stage, this Git is used. Git is a version control tool. Okay. So likewise, there is a continuous integration. Okay. There is a tool called Jenkins, which is used for integrating these every tool. We have to integrate every tool. Okay, for that we can use a tool called Jenkins. So what happens is that if a new code comes in version control, like if our version control is Git, if the new code comes, then a trigger is generated in Jenkins. Okay, a trigger is generated in Jenkins, and in Jenkins we will mention our build server. There will be example if we have a Java code, and if we have a Maven build system, that build will occur in our Maven system. Okay, so Jenkins is used to integrate these all tools. Okay. Okay, so there will be, that is continuous integration. So in DevOps, the integration will be done continuously. Okay, the process of integrating new code written by developers with main or master branch frequently. Okay, then there will be continuous delivery if the process is then after build there will be a testing stage. Okay, the testing stage. After that, if the test is success, it will be go to release stage through Jenkins. It will be go to release stage, and in Jenkins itself it will be return to which server or to which server it need to be deployed. It will be given in Jenkins. Okay, then it will be deployed. So continuous integration after continuous integration and continuous delivery is done. Okay, and there is continuous delivery and there is continuous deployment. The main difference between is that on continuous delivery, manual interference is there. Like we have to approve the if all tests are okay, we have to manually approve that. Like some companies will only release the new version on weekends or on Fridays. So that companies will manually go to the after the all test is success, they will manually go to the deploy stage. Okay, so that is some companies will automate that also. Okay, after the testing is completed, they will deploy to the next stage. That is called continuous deployment. And if a manual intervention is there, it is called continuous delivery. Okay. Then there are some infrastructure concepts. Okay. We will configure. Infrastructure concept is the first one is configuration management. Okay, we know that for like if you have a very big e-commerce website, like for example Amazon, there will be many servers. There will be many servers, and some servers will be running Ubuntu, some servers will be running Amazon Linux, and some likewise many servers will be running many OS versions, and it will be running different types of services. Okay, so we have to manage this. Okay, so in order to manage this, we use configuration management. Okay, there are many configuration management tools like Terraform, Ansible, etc. We will use for configuration management. Okay, then there is cloud computing. Like I said previously, on-demand availability of computer system resource, especially data storage and computing power. Then there will be infrastructure automation. That is like if we need, if our infrastructure needs to scale up and scale down, we have to automate that. We will take the input from. We will monitor the services, and if any high load is coming in any service, that only that service will be scaled up. Okay. And then next one is the artifact management. Then on development process, some artifacts will be developed. For example, while creating Java using Maven, some artifacts is created. We have to store that artifacts for reusing purpose, or for there will be certain versions for these artifacts. So we have to save this in a repository. For that, artifact management is used. And the next one is containers. In development process, we have heard that this application runs on my computer, but this application is not working on another computer. Like that, we may have heard. Okay, for not having that problem, we will use containers. Containers is like I earlier told about virtual machines. Okay, containers is like a small virtual machine inside the virtual machine. Like it will have a it will have a small OS, like it will have Alpine. You may not have heard about Alpine. Alpine is a small version of Linux. Uh, Likewise, it will have, so in that container, our application will be running. Okay, so the container will be running in our VM or our on-premise server. Also, we can run containers. Okay, the concept is that container is um, container is a small is an encapsulated form of a operating system in which only the services which we need are only installed in it. So we can save the storage, and we provide this much amount of RAM, this much amount of memory space, etc. to the containers also. Okay, so our application will not be using will not be using more amount of RAM and all, as it is mentioned in the containers. Okay, the next one is pipeline in DevOps. Okay, as I said, the key practice in DevOps is continuous integration and continuous deployment. Okay, and in DevOps we will be managing many environments like dev environment, code analysis, testing, UAT, production environment. There will be many environments. For example, the developer will be testing on a dev environment, and there will be some QA testers. They will be testing on testing environment, and there will be another environment. There will be production environment. There will be it will be open to the customers. Okay, so there will be many environments. So we will manage all the environments through CI/CD tools. Okay, this is one example for CI/CD pipeline. CI/CD is continuous integration and continuous delivery or deployment. Okay, continuous integration is also called as build pipeline. Okay, that is build is done in continuous integration, and on continuous delivery or deployment, release is done. If our application is released, it is done in this pipeline. Okay, the first step is a change is committed. Like for example, in version control, we told a new code came to the version control. Okay, a developer pushes new code to the Git. Our version control, suppose if our version control service is Git, a new code is committed to the version control. Okay, then our CI/CD integration tool, for example, Jenkins, it will trigger a build. This will be done by there will be integration from Git to Jenkins, and so Jenkins will know when the new code is coming. The Jenkins will know. Okay, and then that trigger build is happened. So on there there will be many steps to which like if that is a Java code, and if Maven build machine is to be used, then that build will go to this build machine. Okay, if any other code has come, then if we have already configured our Jenkins server, then that code will go to that build machine. Okay, likewise many build machine we will have set up. Okay, so here after the trigger build, and this building is done. Okay, then the outcome of our build is notified to the developer. Like if the build is successful or build is failed, it is notified to the developer. Okay, this will be done on some tools like Slack. Slack you may have heard. On some tools like that can be used for sending messages to, or we can use SMS or email a notification we can send. That is done. Then after that, some tests are run. Okay, some after that some tests are run, and this will be done in a test instance uh, or for testing some automation. There will be some automation testing tools like Selenium, etc. There will be after testing, that output also will be notified to the developer. Like if test is failed, he may have to change his code and commit again. Okay, then that is notified to the developer. Okay, if the test is success, then our project is gone to the delivery stage. Like I said, there will be many environment, dev and code analysis, test, UAT, production. Like this will be done for every environment. This will be done. Like if the dev environment itself it fails, it will not go. It will not go to the other stages. Like it will not go to the code analysis stage or another stage. It will not go. It will not go. Okay. So if for example, if the dev so here it will deliver the build to the dev environment. Okay. So here if you are using continuous delivery, a manual intervention is needed for it to deploy to the dev environment. Otherwise, if we are using automation or testing also, if the test is a success, we can move to this environment. If we have defined like that, manual intervention is not needed. Okay, then it will deploy where necessary. Okay, this is CI/CD pipeline in DevOps. Okay. This is the DevOps lifecycle. This is the steps. First one is the plan. Like I said, and the requirements and all is gathered in this stage. Then then there will be a coding stage where according to this plan, the code is created by the developers. And this plan code build and test stage comes under dev, and the release, deploy, operate, and monitor comes under ops. Okay. And then coding is done. Then, like I said, build is done. Okay. Then build is done. Okay. In build stage, the code is compiled, dependencies are resolved, and the software artifacts are created. Okay. And then next step is test stage. Okay. At this stage involves testing the software's functionality and all. This stage will test. Okay. The next stage is release. And in the release stage, it involves preparing the software for deployment and making it ready for users or customers. Okay. From this stage, it is the main responsibility for ops team. Okay. So in release stage, the ops team should ensure that a software is stable and it is meeting the defined requirements and all. The ops team should check. Okay. Then the next stage is deploy stage. Okay. In this stage, the software is deployed to the production or deploy environment. It is deployed to that environment. Okay. Then further operations is done in the operate stage. Like if some errors came and we need to patch something like that, it will be done in this or it in operate stage. And the next stage is monitor. Okay. We in DevOps we always monitor the underlying infrastructure and the underlying infrastructure, etc. We always monitor. Okay, and this comes under monitor stage. Okay, and if any error or any unusuality come, it will again go to plan stage and it will continue. Okay, this is the main DevOps life cycle. Okay, and here continuous monitoring is done. Okay, and after monitoring, if any error or any high load, anything like that come, the notifications will be sent, like email notification, SMS, or Slack notification. It will be sent. Okay, so plan, code, Git, Jira, Conference will be used. Then for building, Maven will be used. For test Maven or else any build it depends on our code. And then for testing there are some tools like Selenium. And then for release and continuous integration we will use Jenkins, CodeShip, and for deploy we will use the release will be deployed to AWS, Docker, like that it will be deployed. Then for operation we will use Chef, Ansible, Kubernetes, etc. will be used on operate also. Okay, and then the next stage is monitor. For monitor we will use many tools like Prometheus, Nagios, Splunk, Datadog, Zabbix, etc. We will use to monitor. Okay, so everything will be continuously integrated and continuously monitored, continuously everything will be done continuously. Okay, these were some tools. Jira, which will be used in planning and coding phase. It will be used for issue tracking tool. The requirements will be gathered into this tool, and with respect to this tool, the next further process is done through this, like the version control, etc. Can be controlled through this software, this application, and this tool. We can some of the Jira's capabilities are project management, then issue tracking. If a new issue comes, we can directly raise a ticket here, and we can track that issue, like what is the status of the issue, uh, to which developer it is assigned. Like that, we can track that here in Jira. Then task management, like I said, to which developer it is assigned. It will be available in Jira. Then full collaboration and communication between the developers, operations team, and QA team, etc. The whole team will be using Jira. Then it can be customized, and other tools can be integrated. Okay. The next tool is Git. Git is a version control software. It is used for tracking changes in source code during the software development. Like I said, if new version is to be released, the developer will be writing some code and will be uploading that code to this tool. Okay, from this tool, the main code is always fetched from this tool. Okay, and a complete history of revisions will be there. Like if anything happens and we need to roll back to a previous version, it can be the previous version's code will already be in the Git. Okay, so we can fetch the code from Git. Then Maven is a build tool which is used to build Java applications. Uh, for uh, for that purpose, we will use Maven. Okay. In that, the requirements etc. will be given. So with respect to that requirements, the dependencies will be fetched from Maven's repositories, and our build is done. Okay. Then for testing purposes, uh, we can use a tool called Selenium. Okay. For example, if we have a e-commerce website and we need to place a 1 lakh orders at a time, we can use a Selenium for that. It can be used to simulate user actions, automate web application testing, etc. We can use a tool called. There are many tools. It will be dependent on the application we are developing, and these are just examples. Okay. Then for CI/CD, we can use a tool called Jenkins. And for this release, we can use a tool called Jenkins. Here we can use continuous integration, continuous delivery, and continuous deployment. For that, we can use Jenkins. Okay. Build automation can be done. Like if a new code is new code comes to Git, and if new code comes to Git, it can go to build server. That trigger is maintained using Jenkins. Okay, then in Jenkins we have many plugins. Like we have GitHub plugins, Git plugins like that. Many plugins is there. We can use that plugins to use the features of that another tool. Then scalability. If we need to build at a time, we need to build many servers. We can scale our Jenkins server to other servers. Like we can use master slave setup. We can use a master Jenkins server, and we can build our code in another server. Then community support, then user-friendly interface. Then AWS. AWS is a cloud computing service. It have around 200 plus services. Some of the services are compute service, like I mentioned, EC2 for virtual machines. Then storage and content delivery. There are services like S3, IEF, and there are some services for that. And then for database, there are some services like RDS. And for networking, then we can we can do auto scaling and all using AWS. That is scalability and elasticity. Then we can manage the security for our instances or our database, and all. We can maintain the security and all. And there are many AI and machine learning services also. Okay. And here we can deploy our code to AWS. Okay. Our code is deployed to AWS, or we can deploy to Docker. And the Docker can inside an AWS instance also. Docker is installed on like I said, we usually install Docker in a virtual machine. The next one is Docker. Docker enables you to separate application from your infrastructure. Like if something happens to our infrastructure, we can easily create a Docker image and we can use that in another instance. Like Docker is actually is a vast concept. It is used for containerization. Like for example, if we have a Apache web server, okay, we can run the web server in two ways. Okay, either we can run directly on the our virtual machine, or we can run through Docker. Okay, while running through Docker, the steps you should follow is that first you have to install Docker, and then we will get some images. We will get Docker images, or we can create Docker images. Okay, and then while use and by using that image, we can run the Apache. Okay, we can run Apache service itself, or we can run the Apache through the Docker instance. Okay, so the main advantages is that the service while running services Docker, it will be isolated from our infrastructure. Okay, and we can reuse the Docker images to other. For example, we can reuse that Docker image to other cloud providers. Like if we have created one Docker image for AWS, we can use that Docker image for Azure, or we can use in our local system also. We can use Docker. Okay. Then lightweight and, as I said, isolated. Then scalability. We can if we have a web service and we need to scale up it, we can run multiple Docker images. Okay, then continuous integration and deployment. And if we have any changes, we can deploy directly into Docker, or we can run another container. Okay, it is called running an application inside a Docker is called a container. Okay, then it is well suited for microservice architecture. Okay, in DevOps we will use microservice. Mainly we will use microservice architecture. Okay, microservice architecture is nothing but if we have a if we have a application, very big application. Okay, then that application will be divided into many sub services, many microservices. Okay, like for example, if at Flipkart we have a login page, and we have say a product page, like we have many pages. Okay, that pages can be, or that services can be divided into to different services. Like login page will be one service, the product page will be other service. Like for the main advantages is that if for example, if a big billion day comes, okay, then the product page or a checkout page will be having more traffic. so we can scale that page more. Okay, like if we need 1,000 servers for that checkout page, and we may only need 100 servers for product page, so we can manage that. Okay, and that's the main use of microservices. Okay, if we don't use microservices, the entire instance will be entire instance need to be upgraded. Okay, so for that Docker is used. Then Kubernetes is also a container. Like I said, Docker is in Docker a containers is created. In Kubernetes is also a container orchestration tool. It can be used to deploy, scaling, and management of containerized application. Like we use like I said, we can create a Dockerized images and all. Then we can run that images in Kubernetes also. We can run that in Docker, and we can run in Kubernetes also. Kubernetes is very much advanced than that of Docker. We can cluster management is the like one cluster is created with many instances, and that cluster we can manage, and we can scale very easily using Kubernetes. And if any service is down, it will self heal, and others it will recreate the service and all. Okay, then there will be an configuration and secret management, like for passing a secret and passwords and all. There will be a secret management and all. It is a more advanced version of using Docker. Okay, next is Prometheus. Prometheus is a monitoring tool. Okay, Prometheus is a monitoring tool. Okay, like we need to monitor all our servers. Okay, we need to monitor this Jenkins server. We need to monitor this build server, and this Jira. If we are running in our servers, we need to monitor Jira server and our AWS server, Kubernetes cluster, and everything we need to monitor. For that, we can use monitoring services like Prometheus, Nagios, Splunk, Datadog, Zabbix, etc. We can use. Okay. On Prometheus, we can data is collected on every 10 seconds. Data is collected, and a query language is used. Okay, for collection of data, a query language is used, and then we can alert through SMS or email or Slack. We can alert if any server load increases or anything happens, like if any attacks come and all, we can alert through Prometheus. Then there will be metric visualization. This will be done through another tool called Grafana. If Prometheus can be integrated to another tool called Grafana, on which we can visualize the metrics. Okay, then service discovery means it can know if the service is down or if the service is up, or if there is any problem with the service, it can know. That is called service discovery. And then scalability. Prometheus also can be coupled with other Prometheus services. Okay, that's scalability. So that's all for today. So This is the DevOps lifecycle. First phase is plan, then there will be a coding phase, then there will be building, then there will be testing phase, and then the release is done through some tools like Jenkins and all. And then there will be, and then the code will be deployed, or our software application will be deployed. Then there will be there will be operate phase. Then there will be a monitor phase.
Hello.
Yeah,
Thank you, Vyshak, for that informative talk. I'm
yeah,
sure
right.
that we have all learned a lot. We have covered topics like the history, what is DevOps, why DevOps, some deployment concepts and life cycles and tools, right? And
Yeah,
um, yes, the people have been very eager. Must be yes. It was a very interesting topic. Like, and I thank everyone who have joined for this online section, and I thank the FOSS VJCET and the the College of Engineering Technology for organizing such an event. And tomorrow we will be continuing this session and we will be deploying a sample app with Jenkins, right?
yeah, yeah, right.
Okay, okay. See you all tomorrow and good night. Thank you. And
Okay,
again, please do fill the attendance form. The link is provided in the chat section before leave. Thank you.
okay. Thank you. Good night.
Thank you, Vyshak, again.
Yeah, thank you.